All right, so last time we talked about slope, how to find the slope, what slope is, what slope isn't, that kind of thing. And so now we want to actually apply that slope in terms of graphing lines. And so the point of today is we're going to talk about how to graph linear equations. And we've already talked about how lines have constant rates of change, right? What that means is slope, right? Rates of change is slope. And we talked about before that the bottom part of a line is going to have the same slope as the top part of the line. So we've already kind of covered that. Now we are going to talk about the slope, the y-intercept, and graphing lines today and writing the equation of lines. We're not going to worry about the x-intercept just yet. Okay, and the next bullet point we'll worry about next time as well. So first things first, some vocabulary for you. First thing is a parent function. We're going to talk about several different types of functions in this class, a linear function being one of them. Quadratic functions, absolute value functions, those are other families of functions. The parent function is the simplest form of that family of functions, right? And then for a linear function, that simplest form looks like this. Y equals x. No numbers around it, just y equals x. The slope is 1, the y-intercept is 0, which we'll talk about in a minute, but that's it. Okay, and this guy's just showing you function notation that we talked about before, but I know it's been a while. Okay? A linear equation is an equation that models a linear function. This guy right here is a linear equation. It models a linear function. Okay? And lastly, the y-intercept. The y-intercept is the y-coordinate of a point. So it is a point. The y-intercept is a point. But we talk more about the y-coordinate. But it's a point where the graph crosses the y-axis. And we're going to talk about why we discuss only the y-coordinate when we talk about the y-intercept in just a second. Okay? All right. There are several forms of a line. Or better yet, there are several forms of a linear equation. The first one we're going to talk about, and the most popular one, is slope-intercept form. I know you've seen this before. Y equals mx plus b. Okay? Remember that m stands for the slope. That's what we used last time to represent slope. And b is the y-intercept. And it's just a number because remember that the y-intercept, while it is a point, we just talk about the y-coordinate of that point. Okay, so let's start being able to identify the slope and the y-intercept. Okay, well, from the last slide, the slope comes from, so the form is y equals mx plus b. So m is the slope. The slope comes from the coefficient on x, which is right here, and that slope is 5. Or we like to see slope as a fraction, 5 over 1, so we can see that ratio of the vertical change to the horizontal change. But we understand that when we write that in an equation, that we very often drop the denominator since it's a 1. The y-intercept is just 2. That means that the graph crosses the y-axis at 2. Okay. What about here? What's the slope and what's the y-intercept? Hopefully you're thinking that the slope is 1/4 and the y-intercept is 0. Right? There's supposed to be a plus b out here. When there's not one, that means that we must have had a plus 0 because 1/4 x plus 0 is just 1/4 x. It doesn't change. So if you don't see the y-intercept, it's just 0. Okay? What about the y-intercept and the slope here? No, it's not -1, it's not 2, and it's not -10. What's the problem here? Well, the issue is that this is not in slope-intercept form. We need to get y by itself so that we can see the slope and the y-intercept. We need to isolate y. And we did this back in our literal equations conversation in the first unit. Got to get y by itself here. Right? So there's your term with y. Means we need to add x to both sides. We have to undo the addition first before we do anything else to get y by itself. right? So when we do, we cannot combine negative 10 and x, so we just bring them down and make this x minus 10. Now we can undo the multiplication by division, so we're going to divide everything by 2. And here's the thing. The x has a coefficient of 1. And like I said, I want to see my slope as a fraction. So I'm going to pull the x down, leave that 1 behind to make this 1/2 x minus 5. Now I can see that slope much more easily, which is 1/2. And the y-intercept is negative 5. Okay? All right. Now, we want to go the other way. If we have the slope and the y-intercept, we're going to go the other way and write the equation, right? Well, again, that form is y equals mx plus b. So all we're going to do is literally plug these numbers in. We're going to put, sorry, not in for x, the 3/2 in for m. And the negative 1 in for b, so make that minus 1. And we're done. That's it. Piece of cake, right? So how about the equation for this guy? Hopefully you're thinking it's just negative 4x plus 7. Right? Good. Try this one. Stop the video, give it a shot, start the video back up and see if it's right. Did you get negative 2x plus 8/5? I hope you do. Hope you did. That's it. Okay? All right. Now, we also want to be able to write the equation of a line when the slope and the y-intercept hasn't been delivered to us on a silver platter. Right? We need to go find it. So how do we do that? Well, the easiest thing to find is the y-intercept. Again, it's where the graph crosses the y-axis. This is where the line crosses the y-axis, right? What's the coordinate of that point? Well, it's 0, 1, right? What if this line hit the y-axis right here? What would be the coordinate of that point? It would just be 0, 5, right? What if it hit right here? Well, then it would just be 0, negative 4. You're starting to see a pattern? The x-coordinate for all of these points on the y-axis is just 0, right? That's why we only talk about the y-coordinate of the y-intercept. Because the x-coordinate's always the same for every point on the y-axis, and it's always 0, and it's just not interesting for us to talk about. So the y-intercept for this particular line is 1. And now we got to find the slope. Remember, the slope, it tells us the vertical change and the horizontal change needed to get to the next point on the line. Well, we can choose any other point we want, but in order to use the grid lines to help us count, we need to find a place where the line goes through a corner of those grid lines, and so there's one right there. So the vertical change is always first. Vertical means up and down. So we need to go 1, 2. So we have to go up 2. Up 2 is positive. And then we have to go right 1, 2, 3. Right 3 is positive. So our slope is 2/3. That means that our equation is just going to be plug in the slope as the coefficient on x, and then the y-intercept goes out here at plus b. And that's all there is to it. You have to just make up the second point. I mean, you're going to have the y-intercept already as a point on the line. So just go find another point. And it needs to be a point where the grid lines meet so that we can count the grid lines to get our vertical and horizontal change. That'll give you the slope, and we can just plug it into the equation. What about here? What's the y-intercept? Well, crosses right there at -3. What's the slope? Well, remember, the slope is the vertical change that you need to get to another point on the line. What's the vertical change from here to here? When the vertical change is up and down, that's 0. And it doesn't really matter what the horizontal change is. 0 divided by any number is just 0. So now we have a slope of 0. So I'm going to make that the coefficient on x minus 3. 0 times x is 0, right? And 0 minus 3 is negative 3. So we can actually write the equation like this. It's not going to have an x in it. Okay? All right. Try to write the equation of this guy. Okay? Think about that for a second, then we'll walk through it together. All right. So the y-intercept was where? Well, here. At 3. Now the slope. I need another corner, another place where grid lines meet and the line goes and the graph goes through that place, which is right here. So I can use the grid lines to count my vertical and horizontal change. My vertical change first. Well, I need to go down 1, 2. Down 2 is negative 2. I need to go right 1. Right 1 is positive 1. So the slope is negative 2 over 1. So that means my equation is going to be negative 2 over 1, yes, but we drop the 1, and when we put it in the equations, we make it negative 2x plus 3. Okay? This is how you'll see it written most often. So you kind of need to get used to that. All right. Now, we want to be able to use the equation of the line to come up with a graph. So we're going to kind of go in reverse. Well, not really in reverse. We're still going to find the y-intercept first. Plot that first. And then because the slope tells you the vertical and horizontal change to get to the next point, we'll just apply that vertical and horizontal change to get to the next point and to make the 2 dots. Now, we need to graph 3 points, right? Plot the y-intercept and then graph 2 more points, and that would be the way we draw our line, right? So let's make this organized. Let's organize ourselves a little bit. The slope in this equation here is 1/2. The y-intercept is negative 1. Okay, piece of cake. I know the graph hits negative 1 on the y-axis, so that's going to be 1 point. If the slope is 1/2, then that means that the horizontal change, the vertical change and horizontal change that I have to go over to get to the next point is up 1, right 2. So we go up 1, right 2. There's another point on your graph. Now, we consider this. Isn't negative 1 over negative 2 the same as 1 over 2? 2 negatives make a positive, right? So we can actually apply our slope the other way. We can do a vertical change of negative 1 and a horizontal change of negative 2 and still get to a point on that line. That's your line. And so we draw a line through it. And that's how we graph a line. It's that simple. Okay, that's it. Try a few more here. Pick out your slope. Slope here is negative 3. The y-intercept is 4. So we know we're going to go to 4 on the y-axis. And now we apply the slope. Now negative 3 is the slope. But like I said, we need to see the vertical and then the horizontal change. We need to make this over 1. So the vertical change means we go down 3. And the horizontal change is positive, so we go right 1. We want to plot one more point. Negative 3 over 1 is the same thing as 3 over negative 1. So we could try to go up 3 and left 1 for our vertical and horizontal change, but that gets us off the grid. So I'm going to keep working with negative 3 over 1. So I'm going to go down 1, 2, 3, and right 1. and that is the next point. We got 3 points now. We can graph and be very happy with ourselves. Okay? All right. Try this one. Stop the video, give it a shot, and then I'll walk you through it. Okay, what'd you get? The slope is actually -1 over 1 because this coefficient is a 1, right? And we like to see slope as a fraction, so I'm just going to make that whole number a fraction by putting it over 1. I want to see the vertical change and the horizontal change, and that's it. The y-intercept is at 3. The y-intercept is at 3 on the y-axis, right? Always on the y-axis. And now I'm going to apply the slope. The slope says the vertical change is -1, so I'm going to go down 1. The horizontal change is +1, so I'm going to go right 1, and then we land there. I can do it again, down 1, right 1, or I can go back up to my y-intercept and understand that -1 over 1 is the same thing as 1 over -1. So from here, I apply a vertical change of +1 and a horizontal change of -1, and that becomes another point on the graph, and so we just graph there. Okay? Hopefully it's what you got. Okay, last one here. Graph this, and I'll give you a little bit of a hint. This is not in slope-intercept form, so we got to get it there. Okay? But stop the video, give it a shot, and then start it back up, and you'll see what you should have gotten. All right, did you get this? So we have to get it in slope-intercept form first, this equation. So we had to subtract x first, then divide through by 2. Remember that when you're looking at this, I want to make that slope a fraction, so I'm going to pull the x down, leave the 1 behind, we get -1/2. -1/2 x plus 5. That means the slope is -1/2 and the y-intercept is 5. So we go to 5 on the y-axis, plot our point, and then we apply the slope. We do a vertical change of -1, which is down 1, and a horizontal change of right 2. And we go again, down 1, right 2. Those are our 3 points, and so we graph our line. Okay? That's it. That's all there is for this for today, right? So go ahead and get started on your homework. Homework's out in Canvas. Make sure you have that done next time.